Okay, so this is 3.3's continuation video where we're going to look at some different examples. I already showed you one example that is the very typical full analysis of a linear over a linear example. But what I want to show you now is just a couple different ones, and let's, throw in some word problems in there as well. Okay, so before you do a full analysis of a linear over a linear, if you can factor out something and cancel them out, always try to do that first. Okay, so what's going to happen here is I can divide a 4 out of both terms on the top. So I factored out a 4, and what's left is x minus 2. When you notice that the x minus 2 on the top is actually the same as the x minus 2 on the bottom, you can cancel those out. So your graph isn't going to look like the regular graph that has those two L shapes. It's actually just going to be a linear because when I cancel these out, I get 4 by itself. So a line that is just 4 is a horizontal line. Okay, so y equals to 4 looks like this. Now, this circle right here, that gets placed there because at exactly x equals to 2, so that restriction right there, and also because there was one on the top, it's called a hole. So when we've actually canceled the top and bottom by x minus 2, the x equals to 2 part means that there's a hole right when x equals to 2. So there is no way that you could ever have an x value of 2 on this graph. If I put an x value of 2 into here and here, I'm going to get a 0 on the top and the bottom, which means that it's not defined right there. There's no y value. Okay, so if you put any other number into your x's, like let's say 3 and 3, you'll get 4. Okay, so all the x values will always give a y value of 4 except for right here. All right, so that's it. That's the graph. It's actually very simple. Now, if we have a different kind of question, like let's say this one. This is one where you're actually asked to create the equation. So they've given you a bunch of different things like the x-intercept, y-intercept, the vertical and horizontal asymptote. We can use all these pieces of information to create the equation. All right, so you need to know where exactly to look in a regular equation to put these in the first place. So vertical asymptote, this red part. Well, we already know that the vertical asymptote is found at the bottom. It should be negative d divided by c. So instead of a positive 5, I'm just going to put that negative 5 right there, and I'm going to keep that as a 1. Now for the horizontal asymptote, I showed you already what a shortcut is for that. So if it's equal to 2, that's just 2 over 1. So I know that the numbers in front of my x's should be 2 and 1. So now I have a horizontal asymptote of 2, and I have a vertical asymptote of positive 5. All right, well, I'm still missing this letter right here. Your x's and your y always stay in your final equation, but I need to know what that b is. And I can use either of these two to figure it out. This one looks a little bit easier because it doesn't have the decimals, so I'm just going to use that one. Let's put a 0 wherever we see an x, and let's put a 1 wherever we see a y. So 0 and 0, here's our 1. Now we're just going to solve for our b. So 1 times 0 is 0, minus 5. Well, that's going to give me a negative 5 on the bottom. Okay? And then that 2 times 0 is a 0, so then b is the only one on top. I bring the negative 5 to the other side through a multiplication because right now it's dividing. So negative 5 times 1 is negative 5, which means b is equal to negative 5. So I have it right there in purple. Now what I could do is, since I didn't use that x-intercept, that blue, I could always just check to make sure. So if I put 2.5 into my x's right here and here, and I solve, I do in fact get a 0. So then everything works in tandem. The last example I'm going to show you is a word problem. So this word problem is a little tiny bit tricky. An amount of chlorine is added to a swimming pool that contains pure water. The concentration of chlorine, which is C, in the pool at time t hours is given by the certain function. Notice that the function has a linear on the top and a linear at the bottom. Okay, where C is measured in milligrams per liter. What happens to the concentration of chlorine in the pool during the 24-hour period after the chlorine is added? So what you first have to do is graph this, and that means we have to do a full analysis. going to show you the answers, but I think you know how to do this already. Okay, vertical asymptote is -2 for your t. Don't put an x because I don't really see any x's. Okay, so make sure you change the letters as the equation changes. Your concentration has a horizontal asymptote of 2/1. Okay, so that's 2 right there, so C equals to 2. Also make sure that you have your C's and T's inside the chart, and then you're going to test your values. Okay, so this already shows me what the final function should look like, and let's just take a look. Here we have our vertical asymptote at -2, and then we have a horizontal asymptote at +2. All right, and let's take a look at the end behavior. So from the right, it's going towards -infinity, so I see that right there. From the left, it's going towards +infinity, so I see that right here. Towards +infinity of the x's, we're going to have it going towards 2 from below. So +infinity, it's going towards the height of 2 from below that line. Okay, and going towards -infinity, it's going to go towards 2 but from above. So -infinity, it's getting closer and closer to 2 from above. Awesome. We're going to join those and they're going to make our graph. And if we wanted to be specific, we might want to add some intercepts in there. Okay, so the t-intercept is when c is 0. Then you're going to start solving for your t, bring it to the other side through a multiplication, and all of it disappears because 0 times t plus 2 is just 0. That means the 2t is still on this side, and we're just going to solve and we get t is 0. So we have 1 point at 0, 0. Now if you want your c-intercept, you're going to put your t's as zeros, and then you're just going to solve. So 2 times 0 is 0, 0 plus 2 is 2, and then through the division you get 0. So we do have the same point for your t and c intercepts, and that is right here. Okay. Now what I did was I added something extra, which was the increasing, decreasing slope and the y values. Notice that your function, your y values, or in this case your concentration, is increasing in value. So all of your y values are getting bigger and bigger, but they get close to 2 and they never go above. In terms of your slope, so the rate of the concentration is the slope, which is kind of flat, but then it gets even flatter, and then it gets even flatter. So we're looking within a 0 to 24-hour period. That's why it's highlighted in yellow. And we can say that the concentration is increasing towards 2 milligrams per liter, but it's going at a slower and slower rate. Okay, so at the very top, it's going to be an extremely slow rate. All right, so that's how you would use this entire analysis in order to answer a word problem.